Hey guys, Dr. Cliff here. Check out this clip that we took from our full-length interview with Mike Housholder from XMEMS. If you do not know what an XMEMS speaker is yet, you need to check out this video because I believe that this silicon speaker technology is going to completely revolutionize the hearing aid industry. So watch this clip, let me know what you think, and if you want to watch the full interview, I will have that linked in the description. There's very few things that come out that are like, this is such a game changer that if you bought hearing aids 6 months ago, you would want to consider upgrading literally right now, right? And I think that this has the potential to be one of those things.
Yeah, so I mean, starting from the fundamentals, I mean, MEMS technology, microelectrical mechanical systems, really hard to say, it's a mouthful. But,
I like the abbreviation better, yeah.
MEMS is much easier. But I mean, essentially, the concept is they're just microscopic moving structures inside of a chip. So really, what this is, and what we sought out to do was use this new generation of MEMS with Piezo Materials to try to move these structures in a way where we could move air and generate really high quality sound.
And when you say piezo, what do you mean by that exactly?
Yeah, so these are piezo materials that they have a property called the piezoelectric effect. You apply a voltage to them and the material property bends. So that's our actuation, where a conventional speaker uses a coil and a magnet to move a diaphragm up and down. We're using a thin film in the semiconductor sandwich to basically move these MEMS structures up and down.
Nice. And so when we talk about solid state speakers, that's what we're specifically talking about with a MEMS speaker, right?
Yeah, and if we look at data storage, hard drives, mechanical hard drives with spinning disks, now we have solid state drives that don't move. It's just solid state semiconductor electronics. And now that dominates market share. So really the speaker is next. It's the last mechanical component in consumer electronics devices that hasn't gone solid state, and that's our journey, to replace the motor with piezo actuation and then replace the diaphragm that is moving the air. Instead of that being paper or plastic, now it's silicon.
And so what are some of the other benefits of that?
Yeah, I mean, there's the benefits are quite numerous. If we categorize them into benefits to the manufacturer, benefits to the consumer, to the manufacturer, a solid state component just is inherently more consistent and uniform. Every speaker we produce is exactly the same. You don't have any mechanical variance as these things are assembled. They're just natively the same out of the semiconductor fab. Reliability, solid state components are more reliable, so as through consumer wear and tear, they're just going to be more robust over time. And we've also removed the magnet. So we've taken weight out, we've solved electromagnetic interference with Bluetooth radios. Those are benefits to the manufacturer.
Yeah.
Now to the consumer, okay, does it sound better? And the answer is yes.
Right, I mean, that's pretty much all they care about, right?
It sounds good, they'll put it in their ears. So you said that the reliability and the longevity of the device is much better. So what would the comparison be, to something that we have more traditionally, that lifespan versus the lifespan of the MEMS speaker?
Yeah, good question. So we can look at it in terms of robustness. Earbuds and hearing aids, they get dropped. We all have fumble fingers.
Right.
So they're more robust to mechanical stress and dropping, so they're less prone to breakage. But also in terms of moisture and dust, these are IP58 rated.
Okay.
So moisture resistant, particulate resistant, and we even have some of our consumer electronics customers asking us to do washer dryer tests.
Oh, nice.
So leave your AirPod in your pocket, do some laundry. Can you survive a washer cycle and a high heat dryer cycle? These components can.
Yeah, well, you tested on yours first.
Well, and then too, if we're looking at application, down the road toward hearing aids, I cannot tell you how many hearing aids in my career thus far I've seen go through the washer and the dryer as well. So, I mean, if there's any hope of them withstanding something like that, I mean, long term, that would have a really awesome benefit, for what we're doing as well.
Exactly, yeah. So that's really on so it's mechanical stress, it's water, dust, particulate, that's the robustness that you're going to get. And then on the does it sound better side, the answer is yes. But that's really comes back to the solid state architecture, which is the mechanical response of these speakers is about 150 times faster than a traditional speaker. So if you're really trying to produce detail and achieve separation and hear every little note in a song, or really get to really crystal clear wideband voice, these speakers can render that very accurately.
Let's talk about that a little bit more and kind of the direction that you guys have taken with the approach to kind of launching this technology initially through the consumer market and now hopefully targeting more of the prescription hearing aid manufacturer market. Like, talk us through that evolution of everything.
Sure. I mean, I think, again, we think we built a fantastic speaker with a lot of great qualities. Now, how does that appeal to the hearing health community? What we hope the manufacturers see in our product, and many of them are, is, again, they're benefiting from the small size. Balanced armatures have dominated this space because of their small size, and they can get deep in canal. Well, we've matched that size with these MEMS speakers, so we've been able to achieve that small size. In terms of response, we have a wider bandwidth speaker that isn't really tuned to voice frequencies. With hearing aids going Bluetooth, it's not about just voice amplification, it's media amplification. You need a single driver wide bandwidth speaker that can produce all this rich content. And you want something that can do that, very linearly, smoothly, very accurately, without a lot of resonant peaks and valleys that need to be managed acoustically or electrically. So, we think we've built something more attuned to this new generation of Bluetooth connected hearing aids.
If I remember looking at some of the slides when we had our first conversation, it almost looked like your guys' stuff was half the size of the traditional armatures that are used inside of hearing aid receivers right now.
Yeah, I mean, we've pretty much matched the X and Y dimension, the length and the width of a balanced armature, but we're a fraction of the height.
Yeah.
So we can definitely squeeze this into an even smaller space. If you wanted to entertain the possibility of doing stacking these drivers to get additional loudness,
right.
You could stack them and still fit on the same profile of a single balanced armature.
Yeah, interesting. That makes me think of, when we have these hearing aids, we have different power levels of the receiver. So, you go standard, medium, power, super power, ultra power, right, and everything in between. Can you replicate the output of all of those with a single one, or were you talking like once you start getting into the super power and ultra power, you're starting to potentially stack them?
The only reason to stack them is if you need higher SPL. That's all you're going to get. So you wouldn't kind of woof or tweeter it. You wouldn't divide up the frequency ranges. You would stack them to get more overall loudness.
So be a compounding effect with it.
Yeah. But again, it really depends on what frequency range you're trying to target. And again, with the Piezo speakers, they have a unique property that above 800 hertz, they basically just have a linear gain out north of 10 kilohertz. So, I mean, you've got that natural gain built in for those extended high frequencies that that you should benefit from without really having to to deal with resonances or trying to target a driver to a particular frequency range. You've got enough SPL in those higher frequencies.
Yeah, that's a big issue that we have fitting people with steeply sloping high frequency hearing losses. And even the thing that bothers me is that when you get someone who has more of a severe to profound level of hearing loss, you think that you go bigger on the receiver size and you're going to get more gain out in the high frequencies, and it's actually kind of the opposite, right? Once you make that larger and larger, you actually lose the ability to target the high frequencies. So how does that work with the solid state speaker?
Yeah, I mean, with our linear gain, again, we'll be typically north of 130, 140 dB out at 10 kilohertz, and then we're pretty much flat out to 80 kilohertz.
With because you theoretically could have a hearing aid manufacturer that chooses to use, a solid state silicone speaker like the MEMS speakers and not use the venting side of things, right?
Absolutely. They're separate parts.
Right. And so what happens to the frequency response with an open ear canal? Because I would say, 90% of people being fit with hearing aids, I'm just pulling that literally out of the air, but 90% of people who are being fit with either completely open domes or vented to where there is a significant amount of leakage that's happening from their ear canal with sound. So what happens with the solid state speaker frequency response when that happens?
Yeah, so you're with, as with any speaker, when you do have an open fit, you're going to have a low frequency roll off. You're going to lose some of that low frequency energy. And that's typically, depends what that corner frequency is. It could start at 100 hertz or 200 hertz. You'll start to lose some of that deep bass. But everything 100 to 200 hertz and above is untouched.
Nice, even through the high frequencies.
Correct.
Nice.
So anything above 100, 200, completely unaffected.
Yeah. So that would be really nice.
I'm a 30-year wearer of hearing aids, and this sounds really compelling, and where do I get it?
Right. Take my money.
Yeah, right.
I wish I could say, call up Starkey, call up GN, and ask for this part number. We're getting there.
Yeah.
We're getting there, but we're not quite there yet.
Yeah.
I wonder, too, because, obviously this doesn't function in the same way. There's going to be a lot of people who might potentially be bummed out that this probably won't be compatible with previous generations of hearing aids either. If I'm understanding, kind of the integration of the speaker appropriately, it doesn't sound like it's going to be something that could be, previous generation compatible either.
Well, I think in general it will be. I think a lot of the core electronics in a hearing aid, for the most part, will be unchanged. What happens in the digital signal processor in terms of how they tweak and tune the frequency response, that might change, but the core electronics are going to be basically the same. I think what will change a little bit is maybe a little bit of the acoustics for how they integrate the speaker, into the ear canal. But for the most part, the electronics will be unchanged.
Well, I will say that there's 0% chance that these manufacturers come up and like, hey, we just created a new receiver using this technology. Go ahead and pop it on your old hearing aid and get a firmware update. Like 0% chance of that happening.
At least not out of the gate.
Right? Like it's going to be a lot of like, hey, here's a new amazing feature that we have with this new hearing aid that we're launching.
They want to sell a new hearing aid.
Totally,
Yeah,
and I get that because there's going to be a lot of time and money in the research and development of how to include these in their technology. So I do understand that concept. That doesn't happen for free, right? So they have to be able to make it worth their time to invest in bringing on a new piece of tech like this and making it work with their hearing aids, and then potentially completely changing how we, well, maybe not completely changing, but changing to some degree how we approach a hearing aid fitting too. So there's training and education that would go along with that too, and a lot of training and education for new devices when they come out is from the manufacturer who knows how that product integrates and works with their tech. But if you guys want to learn more about XMEMS and everything that they have going on, make sure that you go and check out their website. I believe it's XMEMS.com. And check that out. Of course, we're going to be making a lot more content here on this channel. So if you're not yet subscribed, go ahead and hit that subscribe button with notification bell for more content, and we'll see you next time.